I am happy to announce that I am starting collaboration with QuantFin Foundation. You will find more information about them at the end of the video and in the description.
Hi, welcome to the next fixed income episode in the series. Today we're going to be talking about yield curve. What is a yield curve? Well, basically it's a graph. And because it's a graph, we're going to need a tool to plot something in Python. So there is a popular tool which is called matplotlib. It's a library that enables you to draw different sort of graphs, which is going to need a line graph for today. So you can install it using pip install matplotlib. Let's go to idle. We're going to be using the code that we wrote last time. So I'm just going to open it. It was called 0. Last time we defined a zero coupon bond a class, and today we're going to be using it because it is relevant for the yield curve. So first of all, we need to import the library that we just installed. So we're going to have to import matplotlib pyplot matplotlib pyplot as plt. This is a standard naming. So let's save it and let's run it. There we go. So the library is imported right now, so we can draw a graph. So what is a yield curve? It's a graph that draws what is the yield curve for a given maturity of a bond. So basically the x-axis is the maturities, different maturities that bonds have, and y-axis is different yields that bonds have. So let's start with maturities. Let's define maturities first. So we're going to have maturities. So the standard maturities for bond markets is 2-year, 5-year, 10-year, and 30-year. So now let's check yields. We're gonna take what is a market yield. So let's go to Google and let's check what are the current US Treasury bond yields. So as you can see, I googled bond prices, but what Google Bloomberg is giving is actually yield. So this is, as I mentioned before, this is the standard convention to quote the prices of the bonds by yields. So let us write them down. So we have yields equal to 0.0249, 0.0246, 0.0266, and 0.0306. So there we go. We have both maturities and yields now. So what we're gonna do is we're gonna draw a graph now. So how we do that? We imported the plot as plt. So now we're gonna use it. So we're gonna do plt. There's a function called plot, and we basically give, it's quite versatile, but we can give it just like x values and y values. So in our case, this will simply be maturities and yields. What's that? Brackets. So an object is created. So right now, in order to see it, we're gonna do plt show, and a something pops up. So this is a graph in which we have maturities 2, 5, 10 and 30 years, and against those maturities we have yield of the bonds plotted. So as you can see, it's an upward slope. That means that the longer the maturity of the bond, usually the higher the yield. It's not always the case, but for instance here, so the 2-year is right now higher than 5-year yield, but usually it is upward sloping. Why is that? Well, if people invest for longer term, they basically expect to have a higher yield. All right, so why is this useful? Why is yield curve useful? Basically, apart from the standard bonds that are quoted in the market, 2-year, 5, 10, 30 years, there are also another bonds, let's say something in between, like 15 or 7 or 20 and a half. So those are not as liquid as the standard maturities. So basically we need to somehow get the price of those bonds. And how we do that? We do it via interpolation, basically. So we look at the prices of standard maturities, 10-year, 5-year, because they are quite liquid in the market. So we know that the price is quite good over there, quite sharp. And we interpolate between those prices. So let us give it a try and let us price a bond which is somewhere else, which is not a standard maturity. Actually, in order to show you why it is useful to use yields instead of bond prices themselves, what we're gonna do is we're gonna act as if we didn't know what is the 10-year yield, and we will try to guess it based on the remaining quoted prices that we've got, and we'll see how are we doing. So first of all, let's before we do that, let us calculate what are the current prices of those bonds that we have in given those yields. So what we can do is we can use the script that we wrote last time, which basically is transforming the price of the bond into yield and vice versa. So what we can do here is we can create a array of prices called prices equals to an array. So what is going to be in the array? So we're gonna first of all define an array of bonds. We need to first of all define the array of bonds. So let's write bonds so that we can use those methods of this object. So bonds is going to be an array of 0 coupon bonds, we're gonna have to pass a maturity to that bond. So we're gonna use the maturities that are defined in here: 2, 5, 10, and 30 years. So we're gonna say when we create each of those bonds, it's gonna have a maturity I, and I will be coming from maturities. So basically what this code is doing is it creates an array of objects. Each of them is an object of the 0 class, and it has got a maturity which is coming from this table. So as you can see in one line, using a for statement in Python, you can generate an array of objects, which is quite useful, I think. It's a quite useful feature of the language. So we have the array of bonds now. So we can call them as we call objects from different arrays. So if I say bonds 2, it's gonna call one of these objects from this array, right? In this case, this will be a 10-year bond because 10 is the index, has got index 2. All right, so now let's calculate. We have those bonds, so we can now use the methods for the bonds to calculate the prices. So now we create an array of prices. So it's also going to be an array. So what we're going to do here is we're going to call those bonds. We're going to take iterate through those bonds. So we're going to take bonds with index I, and we're going to calculate the price. So we're going to call this method of 0 class. So we're going to put price here, and we need to pass a yield to maturity as an argument to the price method. So what we're going to do is we're going to use the yields that we defined over here. So we're going to take yields, and here we're also going to take the index I, so that for each bond we pass the right yield. And we need the for statement as well for I so right now it's going to be indexed between 0 and 3. So how we can achieve this is we can write range 0 to 4. So let's try that. Let's call this. So this worked. As we can see that we have prices of the bond. So the 2-year bond with the yield to maturity of 2.5% will have 95. Will have the price of 95. 5-year will have 88.50, and so on. So right now we have the maturities, the standard maturities, the market yields, and we are able to calculate the market prices. So right now what we're going to do is we're going to pretend that we don't know what is the 10-year market price, and we're going to see if we can guess it based on the remaining yield curve. So what we're going to do is we're going to drop the 10-year value from each of those arrays. So basically what we're gonna do is we're gonna use maturity. So let's just drop it. Maturities. The method to get rid of one element from an array is called pop. and it takes argument index of the element to drop. So in our case, this will be 2. So as you can see, it took 10, and right now maturities is without the 10. So we're going to do the same for yields and prices. So, but we want to keep those values so that we don't lose what is the actual market value. So let's call this a market yield. Market yield is equal to yields pop. We're gonna drop the second element as well. So market yield is safe now under this name, so we have it here, and also it has dropped from the original array. As you can see, there's just 3 values now, and we're gonna do the same for the prices. So we're gonna say market price is equal to prices pop 2. Okay, we got it. So now we're gonna try to guess what is the market yield and market price of this bond, of this 10-year bond, and we're gonna see if we can come close to the actual market price. So first of all, so we have 2 possibilities. We're gonna take interpolation, and we can either interpolate between yields or prices. So basically, in both cases, we're gonna be interpolating between what we know. So we're gonna take a 5-year and 30-year, and we're gonna figure if it's better to interpolate between yields or prices. So, for instance, in order, before we do that, we need some sort of tool to for interpolation. So one of the possibilities is to use another library, which is called NumPy. It's also quite useful. So let's import it. NumPy is also quite useful for any sort of scientific use for Python. Import NumPy as np. So it's got a function which is called interp, as far as I remember. And how it works is this. So we want to calculate interpolated price. So this is going to be np. So basically we are calling this thing. The function is interp, and it takes 3 arguments. The value at which we want to interpolate, so in our case this is 10 years, and then the x-axis along which we want to interpolate. So for us this will be maturities, and what we want to interpolate. So in our case this will be prices. Let's check. Okay, so as you can see, it produced something which is a price which is 78.9. So this is somewhat close to the original price. We know that this is a true market price, and this is the one that we guessed based just on interpolation between the prices of the bonds. But let's try something different now. Let's try to instead of interpolating prices, let's try to interpolate yields. So how are we gonna do that? We're gonna define interpolated yield, and we're gonna use the same method here. np interp, So the value at which we want to interpolate is still 10. We use the same maturities, but now we want to interpolate yields. So let's see what it comes up with. So this is yield that is coming from the interpolation. This is the original yield. This is also not quite the same, but let's see which one is closer. So what we're going to do is we're going to use this yield in order to calculate the price that is implied by this yield. So what we're going to do is we're going to use the same bond that we generated before. So the bond with the index 2, which has got a 10-year maturity. And what we're going to do is we're going to calculate price based on the interpolated yield. And let's save it somehow. Let's call it price from interpolated yield. And let's see, how much is it? 77 and a half. So let us now compare what is the value of this price that we get from the yield, and what is the value that we get from just interpolating the price. So the original market price was 76.9. This one, which is coming from the interpolated yield, is closer to the market price. If we simply interpolate the price, we're just gonna have 78.9, which is further from the true market price. So we can see that actually, maybe if we can get the plot back. So right now it doesn't see the 10-year, but what we saw from here, it is basically drawing a line between 5 and 30-year, and what we calculated basically from the interpolated yield is this value, which is different to what it was in the beginning. We can try to put a second graph on top of it. So what we need to do is we can draw a second line. Just call the initial values. Of maturities and initial values of yields. So this was the original graph. So what we saw is that the yield interpolation is working better basically than the simple price interpolation. what we can infer based on this information is that yield curve is quite useful when it comes to interpolating the prices of the bonds that we don't know. So if we just have a couple of points like 2, 5, 10 and 30, we can calculate pretty much the rest. So this is actually the main use of the yield curve, so that you can based on just a few of values that you see in the market that are liquid, that are quite deeply traded in the market, you can imply what would be the value for the rest of it. So this is why it is quite useful to use the yield as in the first place as a way to think about pricing of the bonds, comparing them, and secondly why it is useful to have a yield curve, because it enables us to calculate the prices for any given maturity that we really want, right? So we can use any fraction of the year and we will still be able to get a value. Of course, the more points that we've got on the yield curve, the more precise our calculation will be. So it's possible that, for instance, we also know a 20-year point or a 15-year point, and as the network of the points gets denser, we can estimate more precisely what is the value of the yields that are in between, and from that we can imply the prices of those bonds.
As I mentioned in the beginning, I'm beginning collaboration with QuantFin Foundation. It is a Warsaw-based foundation for professional development in quantitative finance. So if you're interested in learning more about quantitative finance, you want to find a job, or you want to meet interesting people, take part in networking events or any type of educational events they are organizing, visit their website on quantfin.org. They are also based, but you can also find some interesting content online from them. I will inform you if there is some events coming on together. I hope you're gonna like it. I'll see you in the next video.